Okay.
Right.
Thanks.
Okay. Let's start. Thank you, everyone. Welcome for GLC Networks webinar. So today I'm not the one who is talking about the webinar because we have a guest here, Naveen, from MANRS. What is it? Organizations. So you are
No, no,
working
no,
in.
no, no. No, no. I work for Graphite Networks based up in Cochin, Kerala, but I'm a
Oh.
MANRS Internet Society.
Oh,
So
okay.
I'm a MANRS.
Yes.
Yeah, MANRS Fellowship is awarded by Internet Society.
Right. Right. Correct. So Naveen, session is yours, and then
Okay, fine.
go ahead. So platform
Yeah, fine.
and
So,
session is yours.
so
Okay, you can start.
this, yes, yes. Thanks a lot. Thanks.
Yeah.
Good evening. I'm based up in India, so my time zone is like GMT plus 5:30 hours. So 1 hour 30 minutes behind you guys. So it's
Mhm.
6:10 here over in India, and we'll be talking about something called MANRS, mutually agreed norms for routing security. So this is a collaboration webinar with GLC Networks Indonesia. Thanks for inviting us. So I'll tell you what MANRS is all about. It is an acronym for mutually agreed norms for routing security. So let me just fix up. The agenda for the day would be like we would be discussing more about routing security, route hijacks, route leaks, IP spoofing, and possible solutions for this. And we have the MANRS action for network operators, for internet exchange points, and cloud and content delivery networks. So our focus will be more on MANRS actions on filtering, anti-spoofing, global coordination, and validation, which is done using RPKI. And I'll just just introduce you to the MANRS ROVA tool that is for RPKI validation, and there is something called the MANRS observatory. Like we'll just try to understand all these things. So this is the agenda for the day. So because we just normally the session would be like 2 plus or 3 hours. That's what I do. So I take the liberty of taking the time till whatever I want. That's how it works out, because it is a mix of concepts, theory plus hands-on lab session. So I think we plan to split it up. Today's session would be theoretical concepts on MANRS. Then possibly on Saturday we have at 11 a.m. Indian Standard Time. I think it should be around 12:30 your time. We have a hands-on lab session on Cisco platform, which I'll be discussing as the session progresses. So so the internet terms, what is an operator? So operator or service provider is an organization running an IP backbone. So it provides access to end users or access to other networks, right? Sometimes you call it as a service provider or a network provider. That's how you classify it. And again, there's another classification called RENs, Research and Education Networks, which provides access to universities and colleges. It's a non-commercial purpose, and it is for educational purposes alone, not education. It is used for connecting education networks. So examples for RENs are like you have in Asia Pacific, you have APAN. So Asia Pacific Advanced Network is for the Asia Pacific. We have EarNet for education and research networks based up in India for connecting education networks, universities, medical universities, etc., etc. So these are non-commercial, meaning that they connect only universities and education institutions. They provide bandwidth connections for that. They provide hosting solutions for that, for the universities and education networks. And last but not the least, you have the internet exchange points, which is an infrastructure where you have ISPs, CDNs, RENs, cloud and content providers connect to exchange routing information, routing traffic, or routing prefixes, so that the local traffic remains local. So this is a German general terminology on internet terms. So again, how do you interconnect? So that's when the protocol like BGP comes into play. So this is just a briefing on what BGP is all about, because when it comes to routing security, BGP is the protocol that is one which we'll be discussing now. So BGP is a routing protocol that is used for exchanging routing information, both V4 and V6 between networks, right? So, and it is classified as an exterior gateway protocols, meaning that it is used for interconnecting two networks. And it runs over TCP, and it uses port 179. That's the standard IETF setup port, and reserved by the IANA. Port 179 of TCP always is used for BGP. So before starting up a BGP session, you have to have a TCP session connection between the between two routers or BGP speaking neighbors, and they need to be reachable. Okay, fine. So that's the BGP basics, and it's a path vector routing protocol, and it sends incremental updates. So it is used in most of the and all the networks, internet backbones, internet exchange points, telcos, and large enterprises. So path vector meaning that so this is a protocol which lists the list of ASs which it has a particular network. A particular network prefix has traversed. That is the meaning of path vector routing protocol. So AS path is one of the attributes that is used for selecting the best path. So we'll come to that as we progress. So there are two types of BGP. One is external BGP. That's the BGP we are talking about. That is used for exchanging routes between two different networks or ISs. So you can implement routing policies. You can implement inbound and outbound traffic. We'll try to understand how do you implement filters for inbound and outbound. We can run iBGP, or you can run BGP inside your network, that is your service provider's network or data center or your enterprise or research and education networks. So that is used for carrying your customer prefixes or the internet prefixes. Okay, fine. So the internet routes and other etc. can be used for for transporting across the operator's backbone. That is again done by iBGP. So I'm skipping the messages because so BGP AS number. So again, AS number is a number that is uniquely given to a particular network if they request, if they want to run BGP. So that is, say, example, it starts with a number. Possibly, your BGP AS number is allocated by your upstream provider, or maybe your national internet registry based up in your locality, or the regional internet registry, which happens to be happening. So what is an autonomous system? So autonomous system is a group of networks. So it is a collection of networks under a single administrative domain, or which has a single routing policy. So usually it is under a single ownership, trust and administrative control. That's the theoretical definition of how you define an AS number. So as of now, there are around 72,000 BGP ASs. So that is regionally distributed. So there are around, I think, around 893,000 prefixes as of yesterday. So, and there are around 138,000 V6 prefixes as of yesterday. So these are the numbers. Just numbers, don't worry about it. It keeps on increasing on a daily basis. So BGP AS numbers, there are 16-bit range and there are 32-bit ranges. So earlier, when I'm assuming that most of you are from the technical background, and you must be having what you call the BGP. You must have configured either Cisco devices, Juniper or Microtech, or whatever the devices you have configured. In my early days, right, when I do the router BGP question mark in my Cisco router, I could see that I had only the AS. I had the liberty to run only the AS number till 65535. That's the 16-bit range. Then the Internet IETF and other standards organizations started understanding that the numbers are exploding. The numbers of networks that are connected to the Internet are exploding. So in that case, they started developing the 32-bit range. It starts from 65536 to some huge number, meaning that you can add any number of networks. So among this particular range, right, you have reserved address, reserved AS ranges, that is 0 to 65535 is reserved, 1 to 64495 is public internet, and 64496 to 64511 is documentation, which is used for documentation and for writing examples on Cisco docs, or maybe Macrotech docs or Juniper docs. So whatever the diagrammatic representation you do for examples, you do use the documentation prefix. And you have the private AS numbers, that is from 64512 to 65534, that is used, that should be used only internal to your BGP AS. It shouldn't be leaked out. And you have 23456, which is the transition AS, which is used for transition from 16-bit range to 32-bit range. So And you have again what you call the documentation prefix for the 32-bit range. So that is listed 655.362.65551, and the public internet is 65552.4.199. So that's how the in the public internet domain, or in the in the public internet, you will be seeing ranges from AS values from AS1 to 64495 and 65552 to 4.199. So these are the ones you would be seeing, or if you are planning to get an what you call if you're planning to run BGP, your upstream provider or your regional internet registry or the national internet registry would be allocating you with any of the AS numbers listed above. So a BGP relationship in this particular example, you call eBGP neighbors or peers. That's what the technical terminology you use. So the configuration is pretty simple. You go to go to the router BGP and the AS number that the service provider or the registry has allocated to you, and configure BGP router BGP 200, and you. The next command would be forming neighborship with the neighbor, the directly connected neighbor, and remote AS of whatever the AS number of the neighbor is. Then you go to the address family and activate the neighborship. So that's the easiest way to configure. For iBGP, it is like you can do iBGP sessions between edges, that is router B to router C. It is not necessary that all the routers inside your AS need to be configured with BGP. So all you need to have is like a reachability between the routers in which to which you are trying to form neighborship. So internally, what you do is like you try to form neighborship. So iBGP neighborship is basically using your loopbacks. So I think most of you guys would have configured BGP in Java. So it is always with the loopbacks. So coming to the AS types, that is what matters as of now. So there are 4 types of BGP AS. One is stub AS, that is meaning that you're a single home customer or your network is connected to one upstream. So some networks in most of the countries, some networks are stub, meaning that they have only one upstream provider. And at times there might be multi-home, meaning that your network is connected to two upstream providers, 2 or more upstream providers. You call it multi-home. So you do multi-home because you just want to make sure that your network is always available and reachable. So that's the reason you do multi-home. And there is a case where there is another AS type that is called transit AS, where if you want to reach any particular network to the rest of the internet, you have to buy transit or a bandwidth from another provider to reach. So what happens is like a provider based up in your locality, if it wants to do business, I mean, if it is providing WAN solutions or connectivity solutions for your enterprise customer, would buy a transit from the Tier 1 providers like AT&T or a Telstra or any other provider, so that they can connect to the networks that are in the rest of the world. So that's how you buy transits. And there is another AS type that is what you call the relation type, that is internet exchange point, where say example networks like research and education networks or other network operators and cloud and content providers would be connected to a single fabric or multiple fabrics for exchanging local traffic and local prefixes. So these are the main AS types you might see in BGP. So in this particular example, it is like you are an upstream network, meaning that you connect to the rest of the world by giving full BGP routing table or just a default to your customer, right? So what your customer would do is like customer would announce their prefixes, meaning that their IP address spaces to the transit. The transit would take you to the rest of the internet. That's how it works. So it can be full routing table based upon your customers' routing capacities or routers capacity, or it might be just a default route. The transit would be pointing to the customer, meaning that the customer needs to reach the transit because the transit has the complete view of the internet. That's how it works. So this is the case if you're a transit, if you're a customer, you're just downstream to the transit, and and the transit might give you a full routing table or a default, that is you receive your customer's route, and in case their customers as well. So meaning that if you are a customer, it's just a downstream network. You connect them to the net, right? You give them the full routing table or the default, and you receive the customer routes. If, say, example, a customer has more customers, the customers, all those routes would be sent to the transit. The transit would carry it to the rest of the internet. That's how it works out. So this is the connection. This is the case of interconnection. So it's pretty simple. It is it is a normal way how things work out in most of the cases. Now the problem is the routing security. The problem is on a daily basis there are routing incidents. If you go to BGP Stream or Curator Labs or Kentic or etc., any of those, Twitter pages, you can see that every day there is an incident that is related to routing incidents. That is related, whenever you call it routing incidents, it relates to BGP. So either it's a leak or a hijack or it's spoofing attacks. So most of the recent incidents that happened was AS 137.996, that is VIT Global Communication, started leaking. This was on, if I'm right, it was on 31st of or 30th of July. And it started leaking around 1,67,485 internet prefixes, V4 prefixes, and it started affecting around 9,759 ASs, that is BGP running networks in around 193 countries. So what happened is like AS 13996 is connected to two upstream providers. I mean, it was earlier connected to Philippines long distance. That is, it was earlier connected to 9304, that is Hutchison, Hong Kong, and they moved on to the next provider, that is 9299, which is Philippines long distance. So what happened is like they leaked the prefixes of the new provider, that is Philippines long distance, to their earlier upstreams, that is Hutchison. So it is a kind of a leak because you're not supposed to leak what networks you learn from an upstream if you're a customer and give it to another upstream, right? So it is not the way how routing works. So this is the case of a classic leak, and I think around 10,000 plus ASs were affected. And because these kind of softwares like Curator and Kentic and BGP Stream keeps on getting those inputs about hijacks or leaks or outages, etc., and they started posting in their websites. So that's how we understand there are leaks happening. So another routing incident was the famous AS 55410 that is based up in, that was on April 16th, I guess. Vodafone-Idea based up in India. AS 55410 started originating around 31,000 plus routes, which don't belong to them. So the problem is, and they started advertising to their upstream, which happens to be, it was peered at an internet exchange point in India, because they peer at most of the internet exchange points in India, because that's how we keep the local traffic local, and it started leaking to the to Bharti Airtel, which happens to be AS 9498, and Vodafone UK, which again is their upstream as well. So 127.8.73, they started propagating to the rest of the internet, in which even Hurricane Electric was it was even sent to Hurricane Electric, and they started sending to the rest of the world, because you trust your peers. That's the problem. And even those prefixes of those 31,000 prefixes, you had prefixes that belong to Google, Microsoft, Akamai, Fastly, Cloudflare, and most of them were affected because of this particular leak. You can see the traffic shoot up graph in that shared by Dogmadori of Kentic. You can see that there is a spike. Okay, so this they just hijacked everything, because the problem is because they don't filter properly, and they don't do proper. They just accept too many prefixes from the peers. That's the problem. So how do you fix it? The MANRS is the only way to fix those kind of issues. So on a daily basis, you would find around 5 to 6 incidents per day. One or two would be related to leaks, or one or two would be related to prefix or route hijacking, or there is lots of spoofing activities as well. So of these three things, incidents or the problems, prefix and route hijacking and route leaks are directly related to BGP. IP address spoofing is related to IPv4 and v6. So it's not directly related to BGP. So we'll be discussing in depth. We have around 150 plus slides dealing with this. So it is a lengthy session. So what is hijacking? So hijacking is an activity or is some network trying to accidentally or deliberately impersonate that he's another operator and starts originating a prefix or a range of prefixes. So the example for it is the famous 2008 YouTube hijack. So in an attempt to block YouTube through route hijack, I mean, what happened is like they started hijacking the prefixes that was owned by YouTube, and it made YouTube being dropped at many locations, at least in the Asia Pacific. So this was in 2008, I guess, was in February. So how do you fix it? You can fix using strong filtering policies, which I would be discussing in detail. So just to bring you about, just to give you a picture of what that particular incident is, like it happened on 24th February 2008, YouTube with an AS number 36561. 865.152.0/22. This is the prefix that has been hijacked. So there are other prefixes YouTube just advertised, but this was the one that was being hijacked. So what happened is it was a long time back. So I remember my understanding was that there was some video on something that was related to something that was disturbing, and the Pakistan regulator asked YouTube to remove it because it was like many years back. So they were not responding to the regulator. So what happens is like they requested the Pakistan Telecoms, which is the national carrier. So they asked them to black hole YouTube prefixes, meaning that people in Pakistan would not be able to access YouTube. What these guys did is they started announcing more specific, that is /22 is an aggregate and /24 is more specific. So they black holed it, but unfortunately these guys are connected to PCCW Global, which is based up in Hong Kong, which was a regional provider there. During that time, they were peering directly with PCCW Global, which happens to be their upstream, and they started leaking that /24 of that more specific of the 208 block, and PCCW started because they trust your upstream or your customer, right? So you start propagating to the rest of the internet. So the rest of the world, at least in the Asia Pacific, starts thinking. I mean, now in the global routing table, you have 208.65/22 and 208.65/24. So BGP works in such a way that if you have an aggregate or a specific, it would the more specific means. So the most of the traffic requesting for you would be redirected to Pakistan, which happens to be a black hole. So somehow, YouTube guys, the Google guys are smart enough. They understood there was a hijack. They started announcing /24s into the routing system. Now into the global routing table or the default free zone, you have 2 /24s matching. But in that case, BGP shortest AS would have been the criteria for choosing. Choosing to the next. Would have been the criteria to send the traffic. So at least they got few of the traffic back, but still since Pakistan Telecom still advertising that 24, meaning that few of the traffic still gets attracted to Pakistan Telecoms, which again is a black hole, right? So again, what happened is like a few minutes time, YouTube started advertising /25s, which is more specific than the 24s, which Pakistan Telecom started advertising, meaning that now you have a bunch of 25s and 24s. Now, because of the longest prefix match rule of BGP, what every router receiving the announcement would start sending the traffic back to you. So that's how they got back the they somehow mitigated the hijack, but again, PCCW started withdrawing all the prefixes originated by Pakistan. So that's how they just stopped the hijack from propagating. So what is the problem? The problem is like, if you look into it, right, because if you look into the propagation of the announcements, it is clear that Pakistan Telecoms leaked it. That's their mistake. Again, the problem is PCCW Global should have filtered what based upon what Pakistan Telecom should be announcing to them, right? Because as a transit, you're supposed to see what your customers are announcing to you. That instead, if they had proper filters placed, they could have stopped this hijack, because they know that 208.65 is not the prefix which Pakistan Telecoms or the customers or the downstream customers wants it, right? So it is a stolen prefix or a hijack prefix. If they had filters of correctly, if they had implement filters properly, then this kind of hijack incident would have been stopped. So this is a famous incident, and this is the reason why things like RPKI and strong filtering mechanism started being implemented in the networks around. So again, there can be two types of prefix hijack. One is same length, meaning that it can be the same length of prefixes hijacked from a different AS. So hijack technically means that, say example, the AS of each, Bharti Airtel Mobility is 45609. They are the ones who are authorized to announce, or they are the legitimate owners of the IP address block 106.193.255.0/24, right? But what happened is, like, suddenly CCNIC China started advertising, which is owning, which is having an AS number 45069, started advertising the same prefix. So this is called a hijack. So why is it called the same length hijack? Meaning that both the prefix length and the prefix are same. So that's the reason it's a same length hijack. So again, more specific is, like, say example, Keynet is announcing 197.136.0.0/14, and the same prefix was hijacked by XLC Hong Kong, XLC Global Hong Kong, and they advertise more specific of that 197, which happens to be a /24. So when we have a /14 and a /24 in the global routing table, what happens is, like, the traffic would be forwarded to the more specific route. So when you have the same length hijack, then what happens is, like, the BGP shortest path, shortest AS path would come into the picture. So if I'm doing it from, am I trying to access, Bharti's any services? Maybe I'm locally in India, so I have a shortest AS path, or to that particular prefix or the services that is being posted on the prefix, I might be able to reach. But if, say example, someone in New Zealand or someone in Far East or Far West is trying to access some services from Bharti Airtel, which might have long prefixes, long AS path, then in that particular case, they might not be able to, they might be redirected to China, maybe because of the shortest AS. So that is the problem with prefix hijacking. So route leaks is something which I told you earlier itself. So some, say example, in this example, I would put it across. So I have a provider in the middle, that is my transit. So that is AS64500 is connected to two customers. One of the customer is single home, that is 64502 is single home, meaning that it is connected to one upstream provider, that is me alone, right? Then I have another customer which is multi-home, meaning that they are connected to my network as well as to another transit provider, which happens to be ASP, right? So my customer, say example, that is single home customer, that is AS64502, wants to reach google.com or 8.8.8 prefix. So what happens is, like, the normal AS path would be like, he just reaches, he just tries to reach Google through my network. That's how the normal routing works. What happens is, like, when another customer starts leaking, say that I have more best path to 8.8 through my network, then what happens is my customer would be taking the path that is the least specific, right? That to reach google.com. That is the case when you call there is a leak. So a leakage is not intentional. It is like because of misconfigurations or some lack of policy planning. You might prefer the customers the customers path over the peer. That's the problem. So leak happens on a daily basis. So leak again is a problem because you're choosing the you're skipping the best path or the best optimal path, and you're taking a path that is not supposed to be the best path. So this is like most of the cases it is because of multi-homing, and you started accidentally announcing routes learn from one provider to another provider. So this is like your customer would be the transit. So that is usually unintentional, and it is not a nice thing to happen, because the case of leak was Wipro based up in India. It's a BPO, and they are announcing a /24, and it was leaked by Globe Telecoms Philippines based up. So they started leaking it, and they started propagating it to Telstra, and it was leaked to Telstra. So that's how it happens on a daily basis. You might see a leak or hijack or an outage. So incidents in South Asia, I just listed out. Most of it would be Indian based, because I had session a couple of days back in India. So I had to put all the stuffs that are localized to that. You can see that most of the reason for hijacks are hijack, meaning that it is wrong AS that is advertising your prefix, meaning that if I'm AS 100 and I own this prefix, and say example, you guys are running an AS 200 and you are advertising my prefix, then again it's a hijack. It's the same length hijack. So when you advertise the same prefix length, if it is, this is more specific, because as I told you, the AT&T internet is advertising /12, and controllers data center based up in Hyderabad, and they started advertising more specifically on the 21st. I mean on the 172. So a /24 is more specific in the global routing table, so traffic would be attracted to them. So, and there was a particular incident a couple of weeks back or months back. This was Info Labs Alpha based up in India. So they were having an AS number, having a prefix 103.239.56.0, an aggregate of /22. So AS server ion based up in US and Netherlands, both the AS, different ASs started originating these prefixes, which is more specific from two different ASs. It's a web hosting company based up in US, and they have an AS number, announcing from Netherlands as well. So they started announcing the prefix that Alpha Info Labs was owning. So that's again a hijack. So these kind of hijack mechanisms you could see, either it's the same length or more specific, or it is the same length prefixes from different AS numbers. Again, it's both. Everything is classified under BGP hijacks. So leaks. The National Knowledge Network, which again is an academic network based up in India, so it started leaked by Vodafone. Again, they are a serious culprit in case of leaking and hijacks. We try to reach them, but they are not very responsive. So they started leaking to level 3 to 3356 and 3549. And you can see the prefixes hijack. Again, Wipro Spectrum leaked to Globe to Telstra. A digital network based up in India, again, Vodafone, the culprit, leaked to level 3. 150.242 is the prefix. Again, digital network 103 was again leaked out to Vodafone. So this is the case where they're accidentally doing it, or they try to do with some kind of traffic engineering or flow spec or whatever things they're doing, but they don't come out in public and say that the reason for what happened, or it was a leak it was a mistake. So from the community perspective, what we try to understand is like, we just guess this is what, or this is what. So that's what we can do. The problem with this, they won't come out and say that, okay, we were testing some optimizers, or we were trying to do traffic engineering or something like that, or we were trying to do some upgradations on something, or we are doing BGP slots spec or something, or DDoS mitigation mechanisms, which again made this. But normally people don't admit the mistakes. That's the problem. So how do you fix it? There are many ways of doing it. You can do prefix filtering, you can do AS path filtering, you can implement RPKI, you can use automation tools like IR toolset, IR power tools, BGP Q3, BGP Q4, BGP SEC, everything can be used to fix all those things. So we'll try to discuss most of it. So this was the problem statement. So any questions on this?
No,
any
not
questions?
yet. Oh,
okay,
yeah, okay, sure.
go ahead. So yeah, fine. Yes. Any
Hello.
questions?
Hello,
Yeah.
Naveen, Mr. Naveen.
Yes. Yes,
Yeah.
sir.
Just I want to know that whether this type of leaking happens at that time, like major company, Vodafone is one of the major company, right? So
Yes, sir.
don't they have put in filter on ingress filter on that customer side? Haven't
Yes,
they
that's
put? Because I think it's a very common that you should put in filter from customer
yes,
side.
yes, 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 yes. They have filters, but the problem is they should have limited the number of prefixes. See, their upstreams or the peers should have limited the number of prefixes they received from Vodafone. In that case, they would have not leaked these many prefixes, right? They have filters. They should be implementing filters. Again, Vodafone's filters didn't work. Airtel's filter didn't work. Hurricane's filter didn't work. That's the problem. That's the problem.
Oh, okay.
That's what we are trying to say. That's what we are trying to say. That's what I said. How do you fix it? I said prefix and path AS path filtering. So that is what we are coming. That's how MANRS is going to help you out in this.
Okay, sir.
So yeah. So actually, so what is MANRS? So MANRS is just what you call. It's just a solution or just a best practice, because you guys are very good in running networks. You are experts in running networks, large networks, massive. Thousands of prefixes generated. I mean, advertised from your networks. You have multiple POPs, multiple AS numbers, V4 and V6. You run the national internet backbones in most of the cases. But the problem is, are you doing the best practices when it comes to filtering or any other routing? How do you mitigate things? How do you fix things? So MANRS is kind of a solution which is not an entire solution for it. At least which will help you to eliminate most of the routing threats. That's what we are trying to say. So what is MANRS? MANRS is used it improves the routing security and reliability of the global internet routing system based on the collaboration from participants and shared responsibility for the internet infrastructure. So MANRS is a new form for routing security. So internet society with a bunch of network operators, internet exchange point, cloud and content providers started thinking about how to fix the routing security, right? So RPK was one of the solutions, but doing RPK based filtering is not only will not always solve the solutions, right? So how do you fix anti-spoofing? I mean, how do you fix spoofing? So there should be something for spoofing. Again, it affects your network. There are DDoS attacks, which is the after effect of spoofing, right? Again, most of the DDoS would be based upon your RFC 1918 address space or unallocated address space. That's how they start doing spoofings or DDoS or any other or DOS attacks, right? And again, how do you coordinate with networks when they are down? Because I'm part of an incident and you are the culprit. How do I contact you? I mean, contact you and try to tell you guys that you guys are leaking my stuffs, my prefixes, or you guys are, I mean, hijacking my prefix, or you are the source of a DDoS attack. So how do you fix it? I mean, how do I talk to you guys and ask you to stop? I mean, stop. How do you fix it? So those are the things we put together in MANRS. So there are three programs, or there are three verticals. One is for the network operators, one is for the internet exchange points, one is for the cloud and content delivery network. So we'll be focusing more on the network operators because 90% of the participants or 99% of the participants will be from the network operators. So this was started in 2014. Internet Society started with a bunch of operators who think that routing security is a big issue. How do you fix it, and how do you address those things? How do you bring collective responsibility to routing and resilience? How do you demonstrate the ability of the internet industry to address the routing issues? Because as an enterprise or a bank or a financial organization, you are not the person that might look into the routing incidents, right? Because it is the connectivity or the upstream providers or the data centers or the connective or the access provider would have to do the routing security part, right? All they can do is that they can protect the network, but they can't do anything about something like prefix hijacking or leaks, right? Because they're not the ones they'll be able to fix those things. So that's when the routing manifesto was introduced. Thereon it started evolving into MANRS. So for implementing MANRS action for network operators, there are 4 actions. So first action is filtering, because that's how you prevent propagation of incorrect routing information. You ensure the correctness of your own announcement and the announcement from the customers, right? It's like what you announce to your customer or your peers or your transit or your leave in a data center, or and what you accept from your upstream or your transit or your customer. So what you send out and what you receive. And again, it's the best practice to how to implement filtering. We'll be discussing in depth. And it is followed by action 2, which is a mandatory. The blue ones are the mandatory ones, and the white that happens to be anti-spoofing is not mandatory. I'll tell you why it is. This helps you to prevent traffic from spoofed IP address sources. And how do you fix it? How do you mitigate it? How do you solve it? We'll be discussing again in depth. So again, action 3 is coordination, which is again a very important step, because as I told you earlier, if I am part of an incident, or I am a victim, or I am the source of some incident, then people have to talk. I mean, other operators need to talk to me or contact me. So I have to update my contact information in the routing databases, like internet routing registry, peering DB, etc., etc. So again, it's a mandatory action, and action 4 is global validation, which your routing information has to be validated in RPK. So action 1, 3, and 4 are mandatory for an operator. Say example, if you are an operator based up in Indonesia, and you want to be part of the MANRS program, then you have to sign up for this. This is a free of cost program. I'll tell you how to join it and what are the requirements you need to do and how you have to join. Action 2 is optional, but there are cases when AT&T, etc. have been doing anti-spoofing as well. Oh my god, my internet is unstable. Just a minute. Hello, am I audible? Hello.
Hello. Yes.
Yes, sir.
Okay.
Yes, sir.
Yeah, fine.
Yeah,
So
there was a disconnection.
because just flapping. So yeah,
okay.
fine. So regarding that, this is the
continue.
network operator. Yes. So we have the IXP program, because this was in 2018 they launched it. They're like, I think around 79 internet exchange points around the globe have joined the MANRS program. So there are 5 actions in this. Action 1 is again filtering, and action 2 is promote MANRS, because internet exchange point is where most of the cloud and content providers, the operators, research and education networks. In India, we have telcos connected at the internet exchange points. You have global caching. I mean, Google Cache, Netflix, everything is over there, because then you need to ask their members to implement it. That's how. So 1 and 2 is mandatory. 3, 4, 5 is like optional, because 3 is like protecting the peering platform, meaning that you shouldn't be leaking all those CDPs and other local kind of stuff which you implement on the fabric, right? So that has to be. You have to filter those things out. And action 4 is global communication, because by the end of the day, they didn't make it mandatory, because IXP, most of the IXPs would be, all the IXPs would be having a mailing list for the directory, for the members, right? So they are in constant touch with the IXP provider. And action 5 is like they have to provide debugging tools to the members, which I think is not a mandatory. So these are inputs based upon the exchange point, because I don't belong to exchange point. I can't comment why 5 is not mandatory. So based upon inputs, it is like 1 and 2 is mandated. So that is how it works. And the latest ones are the CDNs and cloud content providers. That was launched in 2020, and they have 6 actions. Again, prevent incorrect routing information. Spoofing is anti-spoofing is mandatory for them, and global coordination is mandatory, because cloud and content, meaning that they have to have the accessible contact information and peering DB and the RIR databases, and they have to validate it, all the prefixes with RPK or IR, and they have to encourage MANRS adoption for the peers, the customers. And so the 5 actions are mandated for them, and action 6 is like providing the debugging tools, which is again is optional. So because most of the network operators, participants, or most of the big guys like Facebook, I mean, I think Google, Amazon, DigitalOcean, Netflix, everyone are part of the MANRS community. Yes. So let's go in depth with the filtering. So again, it's based upon RFC 7454, which defines BGP operations and security. So it's again a best current practice with a number of 194. So why do you want to filter? So let's check, because my battery is getting down. Let me just fix it. Yeah, okay, fine, no problem. So why do you want to filter? Because you know that if you run BGP, you announce something, you accept any prefix. That's how BGP works. Because BGP does not do anything other than if you form a neighborship, you accept it, what the prefixes your neighbors announce, right? So you don't, unless and until you do some kind of filtering. So why do you want to filter? Because that's your first line of defense, right? Because leave the APK, leave other stuff. Your first point of filter is like what your customers or your upstream or your transit or your peers send to you, right? But when you announce something, right, you know that what you need to announce, you have control of what you announce, but you have no control of what other networks announce to you, right? But if they announce to you, what you can't do anything other than filtering it out. So to avoid issues, you have to decide what routes you have to accept from other networks. So that's how filtering works. So I have a question. Can we extend? Can you give me 15 more minutes?
Yeah, sure.
Yeah, because it's a lengthy topic. Let me just cover the filtering and the other portions. So the operator defines a clear routing policies and implement filters that ensure correctness of the announcement and the customer to the upstream, to the neighboring networks. So what happens here is, let me put out an example. So this is an example of a network operator. You have A64500, which happens to be a MANRS participant, which is happens to be a MANRS participant. It is connected to a transit, which is 64510, and it has a peer with an AS64511. And it has two customers, which are single home stub customers, meaning that they are connected to your network, and your network provides the reachability to the rest of the internet because you are connected to the transit. Because this particular topology is a dual stack topology, meaning you have V4 and V6 running side by side. So this is the reference topology. We'll be discussing filtering or how to implement inbound and outbound filters based upon this topology. Whenever I say inbound filter, it is what you accept from the transit or the peer or the customers, right? When I say outbound filters, it is like what you send to the transit or to the peer or to the customers, or possibly to a leaf in a data center, because I didn't put data center into it. Okay. So outbound filters. So outbound filters make sure that you should be announcing only the appropriate prefixes of your network to your customer, I mean, to your peer or your transit or your downstream, right? And when you do outbound filtering, you have to make sure that you advertise your network plus the downstream customers if you have a downstream. Okay, if your downstream customer is again having a downstream customer, you can send. Advertise their prefixes as well if they pay you to carry the prefixes. So what you need to filter out is like what you advertise is your prefix, your customer's prefix, or your downstream customer's prefix. If they have another downstream, their prefixes as well. And you shouldn't be, you should be filtering things that are non-routable, that is RFC 19 address space, the API pass, the shared address space for the carrier grade net, and IETF benchmarking, IETF TNet, etc., multicast ranges, of those kind of things. You shouldn't be sending to your upstreams or your peers or your customers. So don't accept anything that is greater than /24s in IPv4 or /48s in IPv6. So that are more specific, right? So there's a best practice. That is the reason in the global routing table you won't be able to see /24, something that is /25, 26. There are cases you might see some 25s and 26, but that is when you pay more for traffic engineering or any particular case. you have to pay your upstream to carry that 25. Possibly their upstream might be filtering at 24 boundaries. And you need not send a default because your transit or your peer is not looking for a default from you, right? The transit is someone who has the complete view of their routing table or the complete routing table. So he doesn't need a default from you. So, excuse me. So it is not necessary to send a default to your neighbors. But for your customers, you can send a default because your customers don't have access to any networks unless you send them a default or the complete routing. So outbound filtering based on the diagram. So to the customer, you can send a default to the customer. If the customer has capable routers or they want to have the whole complete routing table, then you can announce the full routing table. And but you shouldn't be sending the default and the tokens, but especially addresses in RFC 19 address box. Means you should be filtering those things and sending to your customers. To your peers, that is possibly at an internet exchange point. So you should be sending your prefixes, that is this particular this prefix of 203.0.113.0/24 and the 1000::36 prefix plus your customer prefixes, all the three prefixes to your peer. So what your peer would be sending is like this 3000::36 or any other v4 prefix or the customer's prefixes to you, meaning that you should be sending this and you should be rejecting rest of the prefixes. Plus from the peer, you should be accepting these prefixes and their customers, and you should be denying the rest of the prefixes. So that is the best practice. So I think that answers the question you asked me. So this is the best practice you should be doing. But the problem is when we conduct workshops and seminars and webinars and hands-on workshops, the problem is most of the guys are engineers, solution architects. They're not the final authority to decide whether to build filters or migrate. Start implementing API. It goes to another set of what you call managers or vice presidents or some decision-making guys who don't bother about it. They just bother about whether the networks are working today. It's fine. Okay, if you have issues, so let's save our face. That's it. They don't come out. They don't want to have something that is some filtering. This is something that can be implemented with the help of a prefix list. Most of the issues would have been sorted out, but again, lack of interest in the community is what matters. Is the problem. So if you want to send any other things, possibly most of the peers would be a couple of mails, couple of phone calls, and say that, okay, these are the prefixes I'm sending. Okay, you create a prefix list based on which you craft your filters. These are the things I'm going to send you. These are the things I'm going to receive from you. The rest of it, I'm going to reject it. So that's how it works out. From the upstream, if you want to send outbound, it's your prefix or your downstream customer prefixes. That's the thing you need to send out. You need not send any prefixes that you learn from your peer. So what happens if you don't have an outbound filter? The problem is, you have an inbound filter. Okay, so if you start, you might leak some prefixes, which is this is just for your customers or something that the rest of the internet shouldn't be knowing of, right? So you have to make sure that you have to make sure that you create filters based upon the correct prefixes that you are supposed to announce. So this is your outbound. So you're a nice person, you know what to do. So you implement proper filters. So that is outbound. That's very simple. Yes.
Question, Naveen. So yes. This is we are filtering for outgoing.
Yes.
So
yes.
We have our own prefix, and then we put the outbound prefix so that if we made a mistake, that mistaken prefix will not be propagated to other peers. And yes, then for outbound filter is will be sent to upstream.
Yes.
Okay, so to the upstream. So it means, for example, so if you have, for example, a big, we have other peers, and then we receive lots of prefix from upstream. Okay, that can be lots of prefixes.
Yes,
like
yes.
700,000 prefix.
Yeah,
so
yeah, around 8 lakh
those of them.
No. That is your inbound filter. I'm saying about outbound. What your network is sending out to the rest of the internet or the peer or the customer. So this is what I own the space. See, just imagine your network. GLC is planning to implement MANRS actions. So what we recommend you to do is implement. So, and this is the prefix you own. 203.0.113 is a v4 prefix, and 2001 DB 8000::36 is the prefix you guys own. Okay, and you have two customers that are connected to you because you are a local provider and you have two customers. And what you need to do is like you have to create a prefix list, and on the prefix list you have to match 203.192.0.2.0 198.51.100.0 and deny the rest of the prefixes. You permit all the three prefixes and deny the rest. Okay.
Okay.
And to the transit and to the peer, you call that, I mean, you implement it on the neighbors outbound.
Okay, outbound.
Outbound.
We also implement the routing filter. We implement the inbound filtering and then outbound filtering. So the purpose for filtering actually is to keep the internet safe from you, and to keep you are still safe from the internet. So both parties are safe.
Both parts. Yeah, because I'll tell you the both part. Because again, so this is outbound. So you are a nice guy, we are a nice guy, we are a nice guys. So we know what we are sending out. But the internet is not what we see, because there are bad actors in the internet. So that's the next portion. What is supposed to be inbound? That's the problem. Inbound best practices is that you don't accept bogan ASs, meaning that the list of ASs I listed, AS 2, 3, 4, 5, 6 is transition AS, private AS, documentation AS. Don't accept prefixes originating from that.
Yes. So this one, I think the service already provided by Kimru, right?
Yes. Team Kumru, Team Kumru provides you with the bogan list. Okay, so this is like manually crafting your filters based upon what you need to accept from the upstreams, right? So you don't accept bogan prefixes that is from Team Kumri. Okay, so Team Kumri gives you the list of bogan ASs and bogan prefixes. If you pair with them, then they would automatically send you the list of bogan ASs and prefixes. Then based on that, you can filter out those things. And the best practice is like you don't accept your own prefix. Okay, you shouldn't be accepting your own prefix. You shouldn't be accepting a default unless and until you request from it, because you don't accept a peer to send a default. You're expecting the default or the full routing table from the transit. Okay. Fine. Sure. And don't accept any routes that are more specific, meaning that anything that is greater than 24, you don't accept in P4 and /48 in V6. And don't accept if AS path is very long. Some guys do AS path depending around. There are cases when you do 250 times AS path prepend. So those kind of things you don't accept.
Like they are doing prepend.
Yeah, too much of prepend. And you can create filters based upon internet routing. We'll try to understand all these things. So inbound, if it is from customers, right? So if it is customer, both the cases, if I am accepting any routes, if it is a provider aggregatable space or provider allocated space, I can know that it is my own space. Then I can allow the customer's announcement back to the provider. That's easy. If it is a provider independent block, what then I need to do is like I need to do a whois and check whether I am a legitimate owner of the address space, right? Either you can do it with whois.appnik, or you can do a joint whois with so that it fetches from 5 internet registries on a prefix and show you who the legitimate address holder is. So based upon this, you understand that this is the right person to advertise this prefix, and you create a prefix list matching that that prefix and accept it inbound. Okay, so this is the example. Your customer is announcing two prefixes, V4 and V6. That is based upon the diagram. So I create a prefix list. So the name is up to you. So I put it as with the AS number, cus4 and inbound, so that I understand it's inbound. because after doing lots of prefix list, I look into it, it's too much of prefix list. So it is like a little bit complicated. So what I do is like, I put the customer AS number, and whether it's V4 or V6, I put V4 and inbound, so that I understand it's inbound filters, right? Then I create a match customer prefix and deny the rest, meaning that my customer might be sending something else. I won't accept it other than the prefix he owns, right?
Oh, yeah.
Okay, fine. So that is my crafting my inbound filter for V4, and for V6 it is like 2001 DB 8001 : 48. So I deny the rest of the prefixes, and in my BGP configuration I go to that as family V4 and V6. I go to the neighbor and call the prefix list inbound, because it is me who is receiving it, right? So I implemented inbound, and I clear my BGP session. Soft in so that it is not tearing up the BGP session, but just refreshing it. And you can see that the rest of the prefixes, if the customer was sending to you, will get filtered. So this is in the lab. Actually, the lab environment we will be doing is like, it is simulating most of the attacks, hijacks and leaks. So once you do the filters, you can see that those prefixes which the customer accidentally or deliberately sending to you will get filters, and you will be accepting the prefixes which your customer should be advertising. So you receive the prefix which he is supposed to send, then you create your outbound filter and send those prefixes outbound to the peers and the transit or in the data center to your leaf. Okay.
Okay.
So this is from the customer. So from the peers, it is like so most of the peers would be like internet exchange points or private peering, right? So what you do is like, again, if you want to do a whois, find out the prefixes of the customers, of the peers and the customers. If you want to do it, it is a best practice. It is always the best to do. Or if you want to create filters, you can use BGP Q3 or BGP Q4. That would help you to automate the prefixes. Have you done BGP Q3 before? Have you used BGP Q3?
Oh, no. This one is new.
Has anyone used BGP Q3?
No, sir, we haven't used till now.
Okay, let me show you how it is. Very simple. Instead of creating, just a minute, let me just start with Ubuntu. So it's already installed BGP Q3, and I give an AS number, AS 17075. 17075 is fiber at home Bangladesh. So now what it does is like BGP Q3 and the AS number. Okay, so it creates a prefix list with the name. So these are the prefixes which AS 10075 holds. So the problem is, what it does is like, it is automatically fetches from the RADB. There's something called RADB, routing database from Merit. It fetches the inputs from the RADB. But our understanding or the best practice we recommend you to do is like, if you want to create a prefix, filters using BGP Q3, always point to a source. That is, say example, my -s appnik or something like that, because the problem with RADB is has lots of if you pay around, I think $500 or something like that, you could create any proxy accounts on a prefix. So let me show you what happens here. Now I just created a BGP Q3. I just generated a filter for AS 10075, which happens to be, say, these are the prefixes available, right? So if I point to a source like appnik, which is an authoritative registry or database, I can show it gives me, just a minute.
Oh, regarding the time here, it's
okay.
2040 now.
Okay, so just few minutes. I'll just wrap it up. So if I put a -s, you can see that it shows only the prefix till. There is no 200 prefix. Okay, so it means that if I don't do a source to any authority, the registry or the registry database, what happens here is it would pull out something that is not relevant. So 203, let me see, do a who is. Let me do a who is minus h who is dot ethnic dot net and the prefix 203.124 96.0/24, right?
Yeah.
So if I do the who is, what happens is like it says that it's GoDaddy.
Oh, okay.
I was creating a prefix to this fiber at home Bangladesh, which happens to be my neighboring country. And if I'm trying to peer with them at an internet exchange point, and I'm trying to create a filter that is for them because the number of prefixes are very less. So what if I try to do something like Vodafone or Tata Communication? Tata is a tier 1, right? So I will not be able to manually type those prefixes. So I have to do some tools like automation tools like BGP Q3 or Q4. So both the cases, BGP Q3 does not support MikroTik. BGP Q4 supports MikroTik. There is no support for Huawei as of now. There is Arista, there is Bird, there is Juniper, etc., etc., etc. So you can create filters. Now you understand that all these prefixes are proxy prefixes, which get fetched by when you try to fetch. When you don't do anything, any point to a database server, it goes and fetches from RADP. So highly recommend to have your filters crafted pointing to a source that is like APNIC or ARN or RIPE-NCC, AFRINIC or LAPNIC. Okay, fine. So just to give you what this thing is.
Yeah.
So inbound filter, use prefix filter, same prefix filter. So accept what the peer is sending, reject the rest of it. Make sure that you don't accept any unwanted prefixes so that you don't leak much of prefixes. So inbound upstream, if you want to get a default, you can get a default. Or if you want to accept the complete routing table, don't accept your own prefix because someone might be hijacking and sending it to them, right? So don't accept your prefix, don't accept bogans, don't accept prefixes that are slash greater than 24s or 48s in V4 and V6. I don't accept default if you don't want. Okay, so this is a prefix filter. So now inbound, you deny your prefix and your customer prefixes, and you allow the rest of the things. That's when the problem arises, right? So that's how things has to be fixed. I mean, you accept the rest of it. You trust your transit to send only legitimate routes, and this is how the filter works out. You address net default, you address RFC 1918, you address carrier grade NAT, shared address space, APIPA, loopbacks, IETA protocol test 1, benchmarking, multicast, etc., etc., etc. Inbound V6, again, you don't accept your prefix, Terodor documentation, automatic 624, 6-bone, ULA, unique local address, link local result, multicast, etc., etc. filter. Only your global global unicast is allowed. So that is what filtering is all about. So again, you can limit the number of prefixes you accept from your peer. So if I say that I want to have 10,000 prefixes along, meaning that I can limit the number of prefixes I from my peer. Say example, if Airtel would have implemented max filtering at their edges that is connected to the Vodafone, they would not have accepted all those 31,000 plus prefixes Vodafone leaked to them, right? So that's the problem. So most of the cases to the peer, it is highly recommend that you reduce the number of prefixes what you expect from them. For the upstream, because you're expecting the full routing table, it's recommended to have a number that is higher than the number of routes in the routing table. Because I can't say that if I want to accept a complete routing table, I can't limit the number of prefixes to 9 lakh or something, because it might overcome 9 lakh within a couple of months. Right? So the rest of the networks won't be reachable to me. So we can filter. I mean, we can from your transit or your upstream, you can accept as many prefixes as possible. So commands are like this. Final filtering is like accept prefixes that are valid, accept prefixes that are length is not greater than 24s, 48s. Accept if you do RPK, accept the valid and the unknown routes, reject the invalids. Don't accept the prefixes from bogus AS number, bogus prefixes, longer AS path, and reject the prefixes that your own prefix. Don't accept your prefix from a customer peer. So this is filtering. So that data sources IRR, peering DB, Bogle list from Team Camry. And so this is how you do this. That is BGP Q3 an example. How it does.
Oh,
So most
okay.
of the examples are, yeah. So Bogan ASS, as I put you out. So if you're planning to peer with Team Camry, so it is like if you plan to have just to have traditional Bogans, which is AS6533, it's a free of cost service. You need to peer with them. So it just filters Martians plus prefixes that are not allocated by hand. So if you want to have a full Bogan filters, then it is like it gives you up to date on what has been allocated end to end, and so that is up to you to peer with Team Camry. So that is the filtering path. Anti-spoofing, if you do, I think we don't have time, right?
I think for this one we can schedule another session for this.
Fine. Yeah, fine.
So
yeah, fine.
Yeah.
Yes. So I'll do something. Let me give the meeting link for that, so that it becomes easy for me to control. Because for the labs, because it's a joint session that has been happening on 11th of September at 11 a.m. Indian Standard Time. Let me just put it to the meeting room, because you'll have people from other organizations attending it. So,
okay.
And there is a limitation because there are 2 platforms for the lab. I think 15 plus 15 is not the max. I could have individual access, so 30 plus participants. 30 participants max.
Okay, so the following session will be on this Saturday.
Yes.
Saturday.
So we'll be on the platform. We'll be on the Internet Society hosted lab platform. So
okay.
you will be doing all those things which we explained over here, like.
Okay, so we'll be doing the. Is that so? There will be, so this session will be on Zoom, and
Yes, everything is Zoom. You'll be able to access the lab. I'll give you the link. I'll give you because I have the admin control, so I can. If there are earlier participants, I can just remove them so that we have enough memory and.
Yeah, perhaps I can share also the information as well to the other group members from GLC Networks.
Yeah, and there'll be few guys from IDNIC, that is, I think, Indonesia Network Information Center. So I had one session with them. I think 2 sessions with them. So they will be guys from the Asia Pacific actually. And we on 13th. Let me just a minute. Let me just show you that before you guys leave. So we are available on conference. So this is our schedule on, that will be 2-hour lengthy session on AppNIC 52. That is, so myself and my colleague will be delivering MANRS. So this is on. This is on 13th September, 11 a.m. That I think this is my time, UTC. So I think it is conference time will be 30. I think it's based upon Korea time. It seems. UTC plus 8. So I think it is Korea plus 8. So we have 2 sessions, one on 13th, one on 11th, and one on 13th. So I can. So you can. Yeah, surely you can join the conference. Is AppNIC, that is the registry that is doing it. You're welcome to join any session. We run the sessions on Saturdays, that is 4 p.m. IST, the Indian Standard Time, because or 10:30 a.m. IST. So I'll let you know, because I put you into the groups. Every day is new audiences, and when I do it in the daytime, right, I have the liberty to extend the session 2 or 3 hours, because if it is late night for you guys, then it's dinner time for you, right? So I do understand it's almost 9 o'clock in your place. So go have your dinner, have fun. We'll get back to you. I slide the slide decks so that you guys
can you show me the session on this Saturday, the date and time? So it's Saturday, 11 September. What time is it? And then the time zone?
It is 11 a.m. IST, so should be
11 a.m.
12:30. I mean, you guys going to have lunch during the session.
Oh, okay. So GMT
Jakarta.
plus, what's your time zone?
GMT plus
5,
5:30.
right?
GMT plus 5:30.
Plus 5:30.
Yes, yes.
Oh, yeah,
yes.
yeah. 5:30. Yeah. India has 30 minutes. Yeah, it's the one and the only in the world.
Yes,
We have
yes,
30
yes, yes.
minutes.
So it's just 1 or 30 minutes. It's almost 7:20 in my time, so should.
Regarding
Yes,
the
yes, yes.
slides.
We'll be sharing the slides. So just send me, share my email address so that you guys can send me, because
Oh, yeah.
so I'll give you access to the slide, because I keep on updating the slide, because every time it is like new audience or new territory, because we deliver, because I have to have regionally specific incidents that can relate guys to it. So yesterday, I mean day before yesterday, it was based on India. So I had most of the incidents focused on Indian audience, because that's when they understand. So I'm part of the incident, or my peer is part of an incident. That's how you work things.
Sure.
So routing incident, yeah.
Last request from the admin. Can we take a picture here? So
Yeah,
everybody,
so
if you don't mind, just turn on your camera and then
yes.
put thumbs up. I'll take a picture. Okay.
So let me take a screenshot as well, because
yeah. 1, 2, and 3. Oh, okay. Somebody here already turned on. Okay, 1, 2, and 3. Okay, great. 1, 2, and 3. Okay, guys, thank you very much for coming today.
yeah, we have.
Yeah, there will be a following session. So the session today should be delivered in 3 hours. If I don't, yeah. 3 hours. So we already have done the first part. So there will be there will be part 2 and 3 in the future.
Yes.
We will inform you the schedule later. So yeah, Naveen.
Thanks a lot.
I will contact you for the next
Thanks
session.
a lot.
Yeah,
have a
guys,
nice.
thank you very much again
Thanks a lot.
for your attention, and then see you in the next webinar. Okay, thank you very much again, and then have a nice day, and keep safe. Yeah.
Have fun.
Thank you. Yeah, keep safe, everybody. Thank you, and goodbye.